compound melting point is the temperature at which it transitions from a solid to a liquid. This is a physical characteristic that is frequently used to distinguish compound or determine the purity of the substance. When a solid begins to melt and turn into a liquid, the temperature is known as the melting point, and illustrations of the connection between structure and attributes is the temperature at which melting takes place, which is determined by the molecule structure. As a result, melting point for various substances typically vary. A pure non-ionic and crystalline organic compound usually has a sharp and characteristic melting point, usually 0.5 to 1.0 Celsius range. A mixture of a very small amounts of miscible impurities will produce a depression of the melting point and an increase in the melting point range. Consequently, the melting point of a compound is a criterion for purity as well as for identifications. A little amount of an organic solid can be placed in a capillary tube attached to the thermometer stem and heat slowly to measure the temperature at which melting starts and finishes. This method can also be used to estimate the melting point of other solids. Typically, pure samples have melting points between 149.5 and 150 Celsius, or 189 and 190 Celsius, while impure samples of the same compound melt at lower temperature and over a wider range, such as between 145 and 148 Celsius and 186 and 189 Celsius. Two common methods for determining melting point using are: first is the melt temperature apparatus, and the second one is a TL tube setup. The general method is to heat the sample indirectly by placing the prepared sample in or on a heat medium. There are other designs such as the Fisher-Jones apparatus.
This experiment, the reagents used are benzoic acid and salicylic acid, and the apparatus used are glass capillary melting point tube, glass petri dish, ruler, and gloves. First, the petri dish was washed with distilled water and make sure to dry it. As shown in the video, we will be using benzoic acid and salicylic acid. The analytical balance was set up and both the benzoic and salicylic acid was weighed. By using the capillary tube, pack the samples into the bottom of the tube by tapping it on the bench top. Repeat this process several times to acquire the height of the samples of 2 until 3 millimeters in the tube. Set up the melting point apparatus into each of the samples' respective melting points. As the temperature rises, monitor the sample through the viewfinder. After the sample was seen melted completely, record the final temperature.
So based on the result above, determination of the melting points of various organic compounds as the main objective of this experiment has been successfully achieved. As the table shown that the melting point for the obtained benzoic and salicylic acid compounds reach the appropriate level of melting, which are 134 degrees Celsius and 158 degrees Celsius respectively.
I will explain the discussion from the result. According to the table in the previous slides, benzoic acid melting point is 135 degrees Celsius, while salicylic acid melting point is 158 degrees Celsius. Hypothetically, benzoic melting points are 134 to 136 degrees Celsius, while salicylic acid melting point are in 158 to 160 degrees Celsius. As the result, the melting point of benzoic acid and salicylic acid are accurate, and the melting points are within scientifically acceptable range.
Before I state the conclusion of the experiment, I would like to tell the definition of melting point. Melting point is a characteristic property of solid crystalline substance. It is the temperature at which the solid phase changes to the liquid phase. Melting point determination is the thermal analysis most frequently used to characterize solid crystalline material. In this part, the theoretical melting point range of benzoic acid melt at 134 until 136 degrees Celsius. Note that our group got melting point at 134 degrees Celsius for benzoic acid, while the melting point range for salicylic acid is 158 until 160 degrees Celsius, and our group got 158 degrees Celsius melting point for salicylic acid. In this case, I can conclude that the experiment is successfully. In conclusion, we can indicate that crystals melt exactly at their accurate melting point. Then they are said to be pure. If they melt at higher or lower than the range of melting point, then they are impure. That's all for me.